going to be implementing a circuit that does a conversion from binary to a BCD representation. But first, I wanted to walk you through some of the background material about how this would work. All right, so the algorithm that we use, or the circuitry method that we use, is called Dabble. It's sort of a well-known way of converting from binary to BCD. Okay, so the double refers to multiplying by 2. Multiplying by 2, by the way, is easy in digital circuits because it's just a shift of the binary representation back to the left. Okay, so for example, if you start with 1, 1 times 2 is 2, which would be 1, 0. 2 times 2 would be 4, which is 1, 0, 0. So you just keep shifting the bits to the left. So that's the double part. The dabble part, we're not going to worry about right this second. All right, so to explain this, I wanted to walk you through an example. All right, so we've done this from the beginning, maybe day 1 of class, where we talked about converting something like 186 to binary. And we did that by dividing by 2. 186 divided by 2 is 93, remainder 0. Divided by 2 again, 46, remainder 1, and so forth down the line. And so you end up reading all the digits coming back up this way to get this particular binary representation of 186. Okay, well, the next thing I wanted to let you know is that you could work this in reverse. All right, so you could start with the number 1 right here, multiply it by 2, and you get 2. So that's our starting point right here, 2. All right, and then we add the next digit over. All right, so let me get the right color. The next digit over is gold. So 0 here, that corresponds to this 0 digit. Okay, then we multiply that by 2 and add the next digit. All right, then we multiply that by 2 and add the next digit. So it's this recursive process that keeps expanding. Multiply that digit by 2 and add that next digit and multiply it by 2. All right, for the purple term, add the next digit, multiply by 2. All right, and then finally, the last two, orange, multiply that digit by, or add that digit in, multiply it by 2, and then add the very last dark green digit in. All right, so that gives you an expansion working this way, essentially backwards from the most significant bit back down to the least significant bit. And from there, you get the value. And if you plug this into MATLAB, sure enough, the value turns out to be 186, like you would expect. Okay, so that's the basis of doubling. All right, there's another way to look at this that I think is a little more straightforward. So let's do an example of that. All right, so we're just going to keep track. Excuse me, I got a cold. We're going to keep track of this doubling process as we go along. So 1 times 2 is 2. We're going to add the 0. 2 plus 0 is 2. And then we double it. All right, add the 1 and then double it. So 4 plus 1 is 5. Double it, you get 10. 10 plus 1 is 11. Double it, you get 22. 22 plus 1 is 23. Double it, you get 46. 46 plus 0 is 46. Double it, you get 92. 92 plus 1 is 93. Double it, and you get 186. 186 plus 0 is 186. All right, so that's the doubling process. All right, we're going to add a dabble in there to take care of making everything turn out in BCD. All right, so I gave you another one to practice by, just something that's even longer. And so you can pause the video, start with this binary number right here, and then go through it, and you get, cover this solution up, go through it, and you get the answer using the doubling algorithm.